Hello and welcome to the part 30 of this video series. In this video, we will learn the difference between a struct and a class. In this video session, we will see how a struct is different from a class, and we will also understand what is a value type and what is a reference type, and we will also understand the difference between a stack and a heap, and at the end, we will understand what is the use of sealed keyword in C#. So let's get started. Okay, structure. In the last video, we have seen structures, how we can create structure and use it in a program. If you remember from the past video, we have used the struct keyword to create a structure. Just like classes, we can have fields, properties, constructors, and methods in a structure. But there are many differences between a class and a structure, which we will explore in this video. Okay, so a structure is a value type, whereas a class is a reference type. So all the differences that are applicable to a value type and a reference types is also applicable to classes and a structure. We will go in detail what is reference type and what is reference type. But for now, let's check the second point. It says structures are stored on stack, whereas classes are stored on the heap. So guys, let's first try to understand what is a heap and what is a stack. Okay, if you notice on this slide, I have example how data will get stored on a heap and how it will get stored on a stack. On the left hand side, you can see we have created two integers a and b, and they will get stored in the stack because these are value type. Again, the value types will get stored on a stack. The reference types will get stored on a heap. Okay, so we have two variables here, a and b, and if you notice, first a will get stored on the stack and then b will get stored on the stack. So whatever will come first, that will go first in the stack, and whatever comes later, that will come after that. So stack, we can say it's a kind of array in that we will store the elements as and when they will come. But in case of heap, it is not like that case. In case of heap, the memory is not organized sequentially. It can be stored anywhere, wherever we have the free memory. Okay, if you see the example here, we have created a string hello, and then we created a string ss equal to s. So what will happen? S variable will get stored on a stack. What S variable will hold? S variable will not hold the hello string, but it will store the memory location where we have the hello string in the heap. Okay, so S will have the value 5000. For this example, at 5000 location, so 5000 is nothing but a memory location. So at this location, we have this hello world string. So at this location, we have the hello string. And when we will say ss equal to s, so double s will also have the memory location 5000 in it. And that will also point to the same string on the heap. And this picture is taken from this particular blog. You can visit this website and understand the difference between a stack and a heap in very detail. So you can check out this blog from Pankaj Patel. And here the differences between this stack and a heap is explained very well and very technically. So if you want to check out this blog, I will add the URL in the description. Okay, let's go back to slides now. Okay, now we know how data gets stored on a heap and a stack. Let's now try to understand how a value type is different from a reference type. Value types hold their value in memory where they are declared, but reference types hold a reference to an object in the memory. If you remember from this slide, when we created this integer a and b, those will directly get stored. I mean, the values of those variables directly get stored on the stack, whereas for the reference type, only the memory location will be stored on the stack, but the actual data, the real data, will get stored on the heap in case of reference type. Value types are destroyed immediately after the scope is lost, whereas for the reference types, only the reference variable is destroyed after the scope is lost. The object is later destroyed by the garbage collector. We will talk about garbage collector in the future videos, but let's now go to Visual Studio and try to understand what is scope and how it will be different for value type and a reference type. I have opened up my Visual Studio. So now let's create a variable integer I equal to 10. Now let's add a for loop. First now let's change the variable name because we already have I at line number 10. Let me call it A. A less than 5, A plus plus. Okay. Now let's create another variable J and let's call it 15. Okay. So if you notice here, the I variable is declared at line number 10. So the scope of this I variable will be from line number 8 to line number 17 because this is the block in which I was declared. But whereas J variable was declared inside the for loop. So the scope of J variable is limited from line number 12 to line number 15. If I try to access my J variable outside the for loop, you will notice we will get an error. If I try to set variable j to 10, you will notice we are getting the error. The name j does not exist in the current context because j is not there in this scope. Okay, let's say I have a different method, public void method a, and if I try to access my I variable here, I will get the same error again. Because I variable is local to this main method, the scope of I starts here where it is declared and it will get end at line number 17. So we won't be able to access I variable in any other method. But whereas if I have a variable at class level, let me call it int x equal to 100, this will be available in method main. Okay, for now let's create the variable statics so that we can access it in our static main method. So you can notice I can easily access my x variable and change the value of it. And if this is a static method, let me create it static again. And if I try to access my variable inside it, I will be able to access it because x is declared in the demo class. So at the class level, it will be available. So the point that we were trying to make, values types are destroyed immediately after the scope is lost, whereas for the reference types, only the reference variable is destroyed after the scope is lost. The object is later destroyed by the garbage collector. If you notice here, once we have executed main method, or once the execution comes out of the main method, the I variable will get destroyed. Okay, it will be done automatically by the .NET framework. Similarly, once the scope of j variable get ends, then the j variable will also get destroyed. So once we come out of the for loop, the j variable will be destroyed. But whereas in case of objects or the reference types, it will not happen like that. Let's say we have a class, public class customer. And if I create an object of my class, customer equal to new customer, what will happen? The scope of this customer variable is in the main method. If I try to access the customer outside the main method, I won't be able to access it. Right? Because you don't have customer in this context. Okay. Once the scope of customer variable gets over, then the variable will get destroyed immediately, but the object that we have created, that will be destroyed by the garbage collector. It will not get destroyed immediately. If you see here, the object will get stored on the heap. So whatever data we have on this stack, that will be immediately destroyed once the scope is over. But in case of heap, it will be destroyed by the garbage collector, and we don't know, we can't tell when the garbage collector will be running. It will be automatically scheduled by the .NET framework. Okay, now let's try to understand the next difference. When you copy a structure into another structure, a new copy of that structure gets created. And the modification on the structure will not affect the values contained by the structure. Let's see this in Visual Studio. Okay, let's create a structure, public, struct, customer. Let's create two properties for it, name and address. Let's create an object for our structure, customer C1 equal to new customer. Let's assign some name to our customer. Let's call it Peter. C1 dot address. Let's call it New York. Anyway. Okay. Let me create a second customer. And instead of creating a new object of the structure, what I will do, I will point it to the C1 customer. So what I'm doing, I'm copying C1 object to C2. Now if I try to modify my object C2.name equal to, let me call it Parker. Okay. Now let's try to print C1 and C2. So we are printing C1.name and C2.name. Let me run this program. You will notice we have the different values at C1 and C2. Even though we have copied C1 to C2, the modification that happened on C2 object are not reflecting on C1 object because customer is a structure. Now let's change this struct to a class. So I will remove the struct keyword and add the class keyword here. And if I run my program now, let's see what will happen. If you notice here, this time in C1 and C2, I am getting the Parker. This is because now the customer C1 is a reference type. So let's go back to slide and understand this again. When you copy a structure into another structure, a new copy of structure get created and modification on one structure will not affect values contained by the other structure. So when we said customer C2 equal to C1, that time a new copy was created. That's why the original object was not affected by the modification. Whereas in case of class, when you copy a class into another class, we only get a copy of the reference variable. Both the reference variable point to the same object on the heap. So the operation on one variable will affect the values contained by the other reference variable. If you remember this slide, when we created two string objects s and ss, that time when we copied value s to SS, both the variable were pointing to the same object on the heap. We did not create any new object or any new copy in that case. Here are some other differences between a structure and a class. Structure cannot have destructors, but classes can have destructors because destructors are used to clean up the memory from the heap and structures don't get stored on the heap. So that's why we cannot create destructors in a struct. Let's go back to Visual Studio and see this. Okay, let me again change it to struct. So customer is a structure now. And if I try to create a destructor here, let's see what will happen. We will get the error message and let's read the error message is only class types can contain destructors. Because customer is a structure type, so we are not allowed to create any destructor inside it. Okay, point number 8 is structures cannot have explicit parameterless constructor, whereas a class can. And this point is valid until C# version 6.0. After this version, we can create a parameterless constructor in structure also. So this point is not valid for newer version of C#. Whereas if I try to create a parameterless constructor within my structure, I have to initialize all the class fields which are available within the structure. Else it will say the name property is not assigned to some value and address is also not assigned to some value. So within this constructor, we have to assign some value to our property. Once we do this, we will notice the error is gone and we will be able to build this without any issues. So guys, from the version 6.0, we can create parameterless constructor in class and in structure also. But in case of structure, we have to initialize the class properties which are declared within the structure. Point number 9 is structure cannot inherit from another class, whereas a class can. Both structure and classes can inherit from an interface. So let's go back to Visual Studio and understand this. So let's create a structure, struct A and struct B. And if I try to inherit structure A here, I will get the error. Type A in interface list is not an interface. So a structure can only inherit from an interface, not from any structure or any other class. Let's say I have a class, public class X. And if I try to inherit the class X, I will get the same error again. X is not an interface. Now let's create an interface, public interface I. And if I try to inherit the interface, you will notice we are not getting any error. And if I try to build the application again, you will notice build is succeeded. But as we have already seen, a class can inherit from another class and they can inherit from an interface also. So just to demonstrate it again, if I have a class Y, it can inherit from class X, no issues, and it can inherit from interface I also. And again, a class cannot inherit a structure. If I try to inherit a structure, we will get the error Y cannot derived from seal type A. So guys, structures are called as seal type. We will understand the seal keyword in a bit, but sealed means we cannot inherit that class or structure. Once we have declared anything as seals, that cannot be inherited by anything else in C#. For an example, if I create my class X as seal type and I try to inherit it now, we will get the error. Y cannot derive from seal type X. So this is the purpose of seal keyword, to make anything not inheritable. On point number 10, we can see some of the examples of structures that are used in .NET Framework. For example, integer is a structure and double is also a structure. Let's go back to Visual Studio and see this. If I create an variable integer I, and if I select this integer, press my control button and go to the definition of it, you will notice the int type is a structure. A class or a structure cannot inherit from another structure, and structures are seal type that we have just seen. And second point is a very important interview question that you might be asked. How do you prevent a class from being inherited, or what is the significance of sealed keyword? That we have seen in this video. If we create any class with the sealed keyword, that class cannot be inherited. So this is the significance of sealed keyword. Okay, that's it for this video guys. In the next video, we will learn about interface in C#.